don't delay it. Okay, let's go forward. As you saw, Fourier transform is a very powerful tool when you need to solve some complex schematics. But there is one question of precision. If you remember, when I started with a general idea, I thought what Fourier, Jean-Baptiste Fourier, created his theory. It's based on foundation of Euclid norm or difference energy as a criterion of precision. It has one backlash. 1 second, I will switch. Oh, here it is. I have tiny demo. Tiny demo. Demo tiny I have. I need to attach my TV. I remember I showed example Fourier decomposition for rectangular signal. Signal like this with the magnitude E by half can be represented by Fourier law as 4E divided by P multiplied by sum from 1 to infinity of sine double P minus 1 double P times divided by minus 1. Auditorium Z. Okay. What do we see? That my signal I showed in reality. Here is component 1, base frequency, base plus here triple, base plus triple. I can clear set original if I add fifth, this is what I show in Y-Flemma generator. Yeah. 100% of base frequency, 1/3 of the triple, 1/5 of the fivefold, and so on. Okay, clear. Can I add 10? Here is row of first 10 components. What do we see? It's closer. You see, it's better approximates rectangle than row of 3 components. We can expect what row of 25 will be better. Here's 25. Better? Better. 100. Better? Better. But something do not disappear. You see this peak? The peaks around the break points, around the interruption point. 250. Many. Do not disappear. And will never. Here is backlash. Here is recoil of average converge. Here is result of base moment. Overall energy is chosen as a precision criterion. Here is result. This peak will never disappear. Or maybe I show. Fourier, when there is a sharp change, Fourier row oscillates around and only then goes to real value. It's a problem of Fourier decomposition of Fourier series. On a slow changing signals, it do not appear. When we have a truly fast change, we see things like this. It was seen from the early days of Fourier row. Lagrange, famous French mathematician Lagrange, was in very strict opposition to Fourier idea because of this. For many years, no one was able to, to estimate this error, to put a light on it. Only 1895, if I'm not confusing something, Gibbs, American physicist Gibbs, researched this, make a special research on this error. From this day, it's called Gibbs paradox. Gibbs paradox problem what Fourier row do not approximate exactly signals with fast or function with fast rapid change. Gibbs paradox. Question: what? Why? Okay, I will switch myself to there because people are watching me, and I will try to follow Gibbs trails. What's going on here? So, idea. I have some kind f of x, yeah. Function which at point A has a break. 2 points A, B. Function when epsilon is to 0 of A plus epsilon is B, and function A minus epsilon when epsilon leads to 0 is A. Maybe I need something like this, function with interrupt. What will we see if we try to break it into Fourier row? Gibbs took approach, we can introduce this break via special function. Gibbs introduced special function. How do you think the name of this function? Of course it's a Gibbs function. If I would introduce special function, it would bear my name. Okay, Gibbs function has values minus 1 minus p x 0 and 1 0 x p. Actually, it's our rectangular function with the e being 1 and only drawn not as a function of time but a function of omega time. Results will be in radians. For Gibbs function decomposition, Fourier law for this function is known. Gibbs function can be substituted as 4 divided by p multiplied sine x plus 1/3 sine 3x plus 1/5 sine 5x plus sine double n minus 1 divided by double n minus 1. We saw it. This breakpoint can be written as divided by half Gibbs function of a point. Moment when it goes up is the fastest possible. When it goes down, again it's the fastest possible. Derivative of Gibbs function at the breakpoint is or infinity or minus infinity. What does this mean? It means what any real existing function will be so fast or slower. It's the fast. Gibbs function represents fastest possible. That means what for Gibbs function and for my example we will see a max possible error. This one is how to say upper boundary. It's a maximum possible error. If we can estimate this error, all real life object will be how to say more precise. We see worst case. We need to take a look on the first n elements of row. Being 4 divided by p, sum where I starts from 1 to n, sine double I minus 1 here should be x divided by double I minus 1. And here is this. In my case now, n is 25. Sum of first 25 elements. And this one is my blue line. This blue line, only here I have degree, should be it should be in radians. Okay, I make it in degrees. So this blue line is my white formula. X here only in degrees should be more correct. Do it in radians. Done is done. How do we research functions? Take derivative. Yeah, we need extreme points. If we need extreme point, this means what we need the Sn from x solve this equation. This equation will give us extreme points. One small problem. We need to solve equation like cosine x plus 1/3 cosine 3x plus 1/5 cosine 5x blah 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 equals to 0. How can we solve such equation? Here's the problem. If we need extreme points, we need to solve equation in sum of cosine. Like I can put parentheses here. I don't know how to do it, but Gibbs knew. Gibbs opened his magic book of complex mass, and in magic book of complex mass there is one interesting moment. As I understand, it's from transient theory. Guys who wrote books of complex mass found solution for one interesting object. A power j alpha multiplied 1 plus a power j beta plus a power j double beta plus a power j m minus 1 beta. Row of vectors. This can be represented as a power j alpha multiplied 1 minus a power j m beta divided by 1 minus a power j beta. What's the idea? Why? Why Gibbs was interested in this row? No, series on series, progression on progression. I don't know. R equals. Gibbs knew complex mass definitely better than I. Because he understood what? If I take a real part of this, will be cosine alpha plus cosine alpha plus beta plus cosine alpha plus double beta and so on plus cosine of alpha plus m minus 1 beta. Idea is think what alpha here is x and beta double x. If you use such substitution, this series will become our equation. Understand? The real part of this series can be represented as our equation of extreme points. This series can be represented as a power j minus 1 bet divided by half multiplied by sine m bet divided by half divided by sine of bet by half. Again, we need a real part. It can be represented like this. If we take real part from it, if we take a real part from this build, we will get real part equals to cosine alpha plus m minus 1 bet by half multiplied by sine m bet by half divided by sine of bet by half. Sine, we have cosine. This thing we can work. Here we have multiplication. This equals to 0 can be solved. We are looking for extreme point. So, cosine x plus cosine triple x plus cosine 5x plus blah 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 plus cosine double n minus 1 x can be substituted with cosine n x sine n x divided by sine of x, and yeah, this can be simplified. Law of cosine can be substituted with one half of sine double n x divided by sine of x. This is solvable. Yeah? Yeah. By the way, if, what is this? This is derivative of Sm. If this is derivative of my Sn, I can write what is double divided by p integrating from 0 to x sine of double n. I will use times say additional substitution variable. My extreme points, I simply need to solve sine double nx equals to 0. This will give me extreme points. Clear why? I don't need infinite point. I need zeros. So, extreme of points are located at positions cut P divided by double n. Here, 1, 2, 3, blah, 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 n. What is K? Number of points. This one, number 1, this one, number 2, this one, number 3, this one, number 4. Where error? Which one is more errors? Where error is high? At point number 1. Number 1 is worst of them. One, 2, 3. This one is worst of them. Question of error. Can we? For this point, magnitude will be 2 divided by t from 0 to p divided by double n sine double n divided by sine of t. Here we need to introduce substitution to solve. Will be divided by p from 0 to p sine y double n sine of y divided by double n dy. Oh. Still no answer, but we can do one trick. For small n, for short rows, but if we go up, which we take longer row, with the longer row, here we have double number of row members, or series members, which you like. There is one trick. Alpha, when alpha goes towards 0, is approximately alpha. For small angles, sine of angle can be substituted with angle value itself. For long series, this one goes towards 0, and we can substitute sine of y divided by double n, when n goes to infinity, by y divided by double n. Yeah? So, for the long rows, error will be, we need to look at double p, sorry, not like this, divided by p. From 0 to p, sine of y divided by y dy. Sine of y divided by y integrate is known. It's an integral sign. We have table for this function. Table of values. Oh, it's 2 divided by p integral sines of p. And its value will be 1179 blah blah blah. What does this mean? That's me. But this overshot in worst case scenario will be 80%. It's a worst case scenario. Don't be afraid of Gibbs paradox. Yes, problem you cannot eliminate this peak in case of fast changes. You will need another. Some are trying to with hard functions, which are. If you need good, really exact representation at this breakpoint, go for velvet transform. Classical Fourier transform will always, I don't know, can I, 500 members. You see, this peak didn't disappear. It will always there. It's a how this row is created. It's because Fourier factors are, calculated, are defined to minimize Euclid norm of difference between signal and its representation. Fourier row, on the other hand, maybe I can up. See my function before p, it's positive, then it up, so sharply draws, but see, it's a point of break. But Fourier row goes through average point. Function, this function is like switching ideal switch. It's a break of continuity here. Fourier row continuous. Fourier row goes through the midpoint or converges averagely. It's a when you for real network where there always is some inductance and capacitance, this is not a problem. For ideal network, if you missed frequency, you will see this overshoot. Fourier row always at sharp changes do overshoot. And maximum difference here, in the worst case, this gap is 18%. Okay, I don't think it's practical to start next topic today. We'll say we will get 1.5. 1 moment, I will check what happens at not here, not here, here. Someone online.